Oh, it's good. Gonna crush my brain. What are you doing? I need to massage my brain. I just found another open source library for creating LLM applications called Semantic Kernel, and I'm confused, very confused. Pretty easy. You see this USB charger that connects the power of electricity to charge all different devices? This is exactly what Semantic Kernel does. It connects the power of your large language model, let's say GPT model, to your own functions and codes or plugins to execute them. For example, you have a plugin to write an email, you have a plugin to play music, or anything. Like Semantic Kernel is an end-to-end orchestrator that let your LLM application execute some task. Better to say, create your own co-pilot. But wait, we do have prompt flow in Azure ML servers that I can create LLM applications in there too. So how these two can get along with each other? Yeah, you can actually code Semantic Kernel inside prompt flow. Would you like to show you a demo? I can actually do that easily. What? Oh, I would love to see a demo actually. Sorry. Yeah. You know what? I need a co-pilot for massage. Can you try my back a little bit just here? Let's go.
Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. Alright, before we get into Semantic Kernel with prompt flow, let's just start with talking about what is Semantic Kernel. Well, this is not going to be a dedicated video just about Semantic Kernel because I believe Semantic Kernel by itself requires dedicated multiple videos actually about it. So if you're interested for getting know with more details about Semantic Kernel, I would love to have your comments. So make sure you write down the comment section. I'll do my best to dedicate more videos just for Semantic Kernel if there are enough interest. So make sure you have your inputs. But for now, we need to have a quick intro about Semantic Kernel. Long story short, it is something similar to LangChain, and I have created multiple videos about LangChain. So Semantic Kernel is also another open source SDK, mainly initiated by Microsoft, but it's pretty active with open source community. That what you can do, you can use Semantic Kernel as an open source SDK to orchestrate connection between your model, like here, for example, ChatGPT model, GPT-4 model, with your programming languages codes like Python, C#. Again, let's say you have created a plugin. What is plugin? Plugin is just bunch of functions, like bunch of Python codes that do something. They calculate math, they write down an email, or they call another API. So those are some action items that you have defined them as a code, let's say Python or C#. And now you need to sort of call them, execute them based on the inputs or the order that your GPT model or OpenAI model generate. So you need sort of an orchestrator that, okay, I see GPT-4 told me that I have to write down an email, so I have to call APIs, codes, or functions that are related to writing an email plugin, as an example. So this is the job of Semantic Kernel. Again, this is a very high level definition. There are much more capabilities we can talk about Semantic Kernel. This is actually the official documentation of Semantic Kernel that I went through that, and they are mentioning a couple of other capabilities, but simply it's all about something like LangChain, as I told you about, and it's becoming pretty popular. This is something similar to what you have seen with Microsoft Copilot, that they have connected to a plugin, they execute some task. So it is like you creating your own Copilot, and you have this Semantic Kernel here to be able to talk with all those APIs, functions, plugins, so on and so forth. Now, then why do we need prompt flow with Semantic Kernel? Again, what is prompt flow? I dedicated a video just about prompt flow and what it is. It's a new service on Azure ML that it will enable you to create large language model application. It will give you code and also a bit of low code visualization of the inputs and steps that you have for LLM. For example, you receive an input for your chatbot, you call OpenAI, you call some functions, and then you have the output of that chatbot. It's a very nice and recent tool. Again, this video is not about prompt flow. If you don't know prompt flow, I will definitely recommend you to check the video that I created about prompt flow before continuing this video. I will add that video to the top right of the screen here and also in the video description. So now we do have prompt flow as a tool to create LLM applications, and now we have semantic kernel to sort of orchestrate connecting my foundation models or large language models to my programming languages like Python. But then why do I need to combine these two, or better to say, what's the proposed value of using prompt flow with semantic kernel? Well, semantic kernel is an open source library, it's a code, and prompt flow is a tool. So semantic kernel as a code can be used inside this tool. But again, what is the proposed value? Let's talk about that. So as mentioned here, the main value here is that prompt flow is a tool beyond just developing application. It's about evaluating application, deploying application, monitoring an LLM application. So when you have a copilot created or a chatbot created that you use semantic kernel inside, you need to evaluate this solution before you deploy it for production. Maybe you have to ask thousands of questions as a sample data set that you have from this solution, and then evaluate the results of that, make sure this semantic kernel, OpenAI models, everything is working properly. And then when you're done, you need to deploy that as, let's say, endpoint, like a machine learning model that you create a real-time endpoint, an API out of it so people can use your solution. For these capabilities, prompt flow will shine, and that's why we need to add prompt flow as an extra salt and pepper on the top of semantic kernel. And this is what we're gonna do. So what we're gonna do in this video, I'm going to create a prompt flow that it received a question from an input from the user. It's a math question. Then I have semantic kernel, which gonna call a function that does math calculation. It uses Python for doing math, no OpenAI, and then the result gonna be back to show to the user. So what I'm gonna do here, I received a question which is the math from the user. I will call OpenAI model to interpret that question to see it's a math, what is it, like what's the request coming in, and based on the OpenAI model output, it is now capable of calling a math function that I define something like a plugin in semantic kernel, calculate that math question, get the results back to the OpenAI model or to the user. And then we're gonna do batch evaluation with testing this solution over multiple math questions. This is the capability of prompt flow, and then we see the aggregated results. Okay, so let's do so. And by the way, recently when I showed you prompt flow in the other video, you saw that I opened Azure ML, but this time the nice thing here is that, let me show you this, there's a new extension of prompt flow added to VS Code. That means I can have the similar experience that I had back in the time with Azure ML prompt flow, but this time with VS Code I can even test it locally and then deploy it to the cloud. So this is great. People who love VS Code, you will love this extension if you're developing LLM application by prompt flow. So let me tell you where you need to start to see what I see here. First of all, clone the repository that I have created. Well, I didn't develop that repo. I cloned that from semantic kernel documentation GitHub and also prompt flow GitHub, but I completed the task, merged them all together to make it clean and ready for you. You just need to clone it. You don't need to do it from scratch, but I'm going to show you how I did it from scratch. So where is that repo? I want to add that repo link of mine to the Discord channel in video description. On the reference section, click on it. You will see the GitHub repo that you can clone it. But let me show you here what I'm talking about. This is what I'm talking about. Semantic kernel prompt flow under my GitHub account. Again, I clone from the references, and then I have it already cloned in my desktop, and then I will show you in the VS Code, and I will go through the files and stuff to see what they are. Okay, just wanted to tell you, FYI, this is the repo I'm talking about, that I will add it to the Discord channel. Okay, going back to the VS Code, the first thing that you need to do is make sure you install prompt flow, and okay, you say pip install. And by the way, as you can see, I am under the folder that I have cloned the repo. Okay, so make sure you come to the path that you have cloned the repo that I showed you, and you would say pip install prompt flow. I'm not going to install it again because I did already. After you're done, install another one, which is called PromptFlow Tools. So two libraries, PromptFlow and then PromptFlow Tools. When you're done, then also make sure you have installed the PromptFlow VS Code extension. How? You could just go to the extension, type PromptFlow, and you will find this. I have already installed that, and as you can see, I have this nice PromptFlow icon added here, and also I have PromptFlow icon added here too, which is great. In order to make sure that you have installed that successfully, you just need to type PF, stands for PromptFlow, and V, which is version. Let's run it, make sure I have it installed on my machine. There you go, it's already there. You're good to go. If you see such a thing, we're all good. So in order to create your first flow, as you can see, this is my flow that sort of calculate the mass stuff. I'm gonna come to that shortly, but let's just forget about now. And by the way, you can see I have cloned the repo I showed you, and these are all the files. Okay, so in order to create a flow in PromptFlow, you don't need to code from scratch, because on the backend side of this flow, there is a code that I'm going to show you. But the nice thing here is that if you just in PromptFlow type PF and then you say flow, and then you say, hey, I want to initiate a flow with this name, for example, perform math. This is what our flow gonna do, right? With using semantic kernel. This will create a bunch of codes, I would say boilerplate code, sort of like a blueprint code for an empty raw flow that you can start modifying it. So when I executed that, that's how I created all these files you can see here for the perform math. There is one, I'm gonna show you what these files are, but that's how I created that. Because you have already cloned my repo, you don't need to execute this command line, because I have already executed and generated these files and I cloned it to my repo. So you don't need to run it again, but just wanted to show you how I created them. So after I ran this, these files got generated, but let's see what they are. For example, the main one, flow.dag.yaml, that's actually the code behind the flow that I showed you. So my flow had input, output, and just a .py code, which is the math planner. And the nice thing is I can change my flow with code here, or click on Visual Editor, that nice Azure ML Plum experience that you have coming in here. So what you saw is the YAML file behind this flow, the input, output, what is the input of this, what's the output of this, it's on the YAML file, right? And there are some bunch of other files, for example, under prompt flow, I think flow details, and at the same, yeah, this one gonna talk about some metadata about each node of this flow that we have here. Or a bunch of source codes. For example, I have to actually delete some of the source codes, they're extra. And let's see what they are. There is requirement.txt. Yes, this one gonna be the libraries that you need for running this flow here. We just need prompt flow for run that, and that's it. So now I have my initial flow created, but again, when I had this created with the command line that I showed you, I had nothing here. It's like there was a hello.py example here. I had to delete this, so I clicked on it, I clicked on delete, and I created this by myself. How? You come all the way up here, you click on plus sign, you say that I'm gonna have a Python code here, you click on Python, then this got appeared. Make sure what I did, I named it math planner, and the math planner.py was created for me. And then I had to, of course, change the code inside the math plan, and I got it from the repository, the reference repo of Semantic Kernel. And what it does here, so let me explain what this math plan does that we're gonna call it. So in Semantic Kernel, when you have a plugin, we do have a plugin, we're gonna call it math plugin that calculate math that I told you. We need to have a planner, because this planner will decide if I'm gonna call that math plugin or not. So it's gonna plan for me. That's what Semantic Kernel does. And because we're gonna call this as a tool inside prompt flow, we need to make sure that we use this decorator here. So it indicates that, hey, this is a function that I'm gonna call it by prompt flow. And you can see it is importing Semantic Kernel for connecting to Azure OpenAI. If it's a chat completion, it will do this for connectivity. If it's a text completion, it will use this for connecting to OpenAI. And how it knows my API key, API base for connecting to my Azure OpenAI, I'm gonna talk about that. Okay, we do have the planner defined, but we have to give some definition to let the model know what this planner gonna do, or how it's gonna call math plugin. I'm going to say that, hey, I have a math plugin. I'm gonna show you later where it is. It's actually here. So you need to use this to solve this problem given by the input. That's it. So what happens after, if Planner decide that, okay, I need the math plugin because that's a math question, it goes under plugin. That's how it is actually importing my math function. It goes plugin, under plugin there's a math.py, and this one, look at that. Instead of OpenAI solving a math solution, which, as you know, these large language models are not good in calculation and math, I have this being done by Python. For example, if the question, now we need to describe what this function does to let the planner decide, and let OpenAI actually help to resolve this. For example, if the user asks square root of a number, I have to clearly define this definition and the input. Then there is a Python code that calculates the square root. There's a Python code that adds a couple of numbers. There's a Python code, for example, you can see it there, do the sum. So why we're gonna do this? Because let me show you something. If I just simply calculate from OpenAI, like GPT 3.5 model here, hey, what is this weird number I added randomly multiplied by this, I got this answer. This is pure chat GPT that answer a math question. You might feel like it's a good answer, but actually it's not, because look at that. I use calculator in my Windows and I asked the same did the same thing. I multiplied these two numbers, and you see that the number is not that bad. Okay, let me come to the calculator. It starts with 55, then 761, but here is 55 778. So there's a difference. That's why they're not accurate. But now with this solution, we are using this planner to offload that execution to a plugin, which is a math that uses Python, a proper calculation. So let's see if that really works properly. So going back to my initial flow, now you know how I created this. I showed you, and it connected to this .py math planner. And because of the math planner.py, it understood that, oh, I have to put some inputs here. So what's the input? Input is coming from the user question on the top. Look, I asked the same question that I asked from ChatGPT, the vanilla ChatGPT, which is here, to see if it's gonna be close to the calculator or not. It's gonna have the same mistake. And then it's a chat completion. This is the deployment that I have created for GPT 3.5. If you don't know what it is, come here to Azure OpenAI. Make sure you use the same name. And remember, I told you how it knows to connect to my Azure OpenAI. That's the place I created OpenAI connection. How? Just click on the prompt flow extension after you install. There's a place called connection. Come on the Azure OpenAI and click on create a connection. That's it. When you click on create, it will ask you that, hey, it created actually a YAML file for you, and it will ask you, give me your key. Okay, actually, let me show you if I can update. There you go. It will create this for you, and you need to just replace that with your Azure OpenAI base. Keep this as an Azure, keep this the version, put your key here, give it a name test. That's why test got appeared, and that's why I have a test here selected. And then click on create or update. That's it. Now I was ready to actually ask my question. So let's actually run this. Let me click on terminal so you will see the outcome. Again, I'm gonna ask the same question that we did here. Where is it? There you go, to see what's gonna be the difference. I copied this, I paste it here. Let me click on run all. So it is running all my flow. It received the input, calling the planner, and based on the question, it will decide for the math plugin, execute that math, but this time not with the LLM, with Python code, and see what's gonna be the answer. Okay, let's wait a bit. There you go. I just got the results, and as you can see, it is 55761. Let's open the calculator. There you go. Now this time I got the exact number I got from calculator, because we offloaded that math calculation from LLM to a math plugin that I had. This was hello world of semantic kernel example inside prompt flow. And just think about this, how many other type of tasks, not just math calculation, you can any other task you can offload out of your LLM, because LLMs are good for reasoning, are good for decision making, deciding on which task gonna get executed by semantic kernel, help, and planner, but they are not good in such these tasks like calculating math or executing an API, they cannot do, but they can help you to decide which API you need to call to fetch a data. For example, here I called my math plugin. Okay, so what's the proposed value again by prompt flow? Now I have this flow, I can test it with batch run. That's why in the repo that you cloned, I show you something. I have something called data.json. If you click on it, I have some, I would call it labeled samples, that here's a math question and here's the answer. Another math question, another answer. And you see the questions are not directly math questions. It talks about pizza, it talks about some weird things. The reason we are doing this to make sure, first of all, the planner of Semantic Kernel works properly and it can understand that, okay, I need to call math plugin. And then here's the output. So I'm gonna give all these to this flow that I created to make sure if the answer is 8, my flow also calculate the answer as 8, or how many of them it will calculate properly. That's another proposed value of prompt flow to let you do batch evaluation. How are you gonna do that? You come to your flow again, you see this one, I think that, yes, batch run, and it's gonna ask you, okay, give me your file. You click on this, you click on data.jsonl, which is this one, and it will start creating the batch evaluation for you. Because I already did, I'm not going to do that again, but when it is done, you can see the results. How? Just come to the prompt flow again. Under batch run history, you see that I have already one created before and got completed. You click on that, you will see yours appears as well. Then when you click on this, click on visualize and analyze. It is now visualizing the results of all the batch data that I have. So let's give it a time and let's see what it's gonna show us. There you go. Now these are all my questions. Remember my sample questions that I have. What was the ground truth and what we predicted? For example, it was 5, we predicted 5, perfect, we got 1 score. The third one, I think we predicted nothing. I have to check why we didn't give a good score, but for the rest we almost calculated it all properly, except one before the last one. You see there's a huge difference. So you can have hundreds of different tests, right? So now I was able to create this batch run and executed that for all the sample data set that I have. But how about this? I want to do an evaluation, another proposed value of prompt flow. So let's say I want to say the accuracy of this solution for calculating math by Semantic Kernel and OpenAI, it is 80% or 90%. So how can I do that evaluation like how we do for machine learning models? Well, in prompt flow, based on the type of the work you're doing, it can do actually evaluation for us. There are different ways. Again, I fully explain different type of LLM application evaluation in prompt flow in the video. Again, I added to the description. Check that out. But here for this specific math calculation, I have again grabbed an evaluation type from prompt flow GitHub repo. That's why when you come to the repo you download it, there's something called evaluate accuracy math codes. And that's why here I have another flow, which is now in my evaluation flow. I click on the flow YAML, click on visual editor, and that's how you see it is receiving that batch evaluation as an input to aggregate that and give me the final accuracy. And there are a bunch of Python codes behind each that they're available here. They're pretty simple. They just grab the sum of all your correctly predicted based on the ground truth that we showed you, all our sample data set. That, and now when I have this evaluation flow, how I applied over my batch run results. So very simple, because now you have this evaluation code in the repo. What you need to do, come to that terminal, make sure you go to the parent path that you have this eval accuracy math to code. So the parent path I have is the perform math. I'm here, and what you need to run is this. I'm gonna show you. Just simply need to say, hey, I pay prompt flow, I want to create a run, and this is gonna be a flow, but this is an evaluation flow. Where is it? This is the path to my evaluation code. So make sure you copy the path that you have under until to this folder. This folder gonna be the same name for you when you clone my repo, but copy that with the path you have. This is mine, and then we're gonna tell that, by the way, with data we use for batch run is here, data.jsonl. Just keep this. You don't need to change anything. For here we are just telling that which column is ground truth, where is the prediction, it's coming from the previous run, the batch run, but where is that batch run? That's the name of the batch run. Yours gonna be different. So how you grab your batch run, and by the way, this is the last thing you need to change, and you can give it a name to your perform math eval, any name you want, doesn't matter. But how did I grab this? Come to your prompt flow, again, extension here. Remember I ran this batch flow that I show you the results of that. Let me show you this one, right? Just right click on perform math, and this time click on view logs. So I will click again, view logs, and there you go. When I saw that this batch run was created, it gave me the run name. That's how I grabbed it actually to my code here. Let me show you again. There you go. That's it. So you ran this in your terminal. I ran it before, we paste it here. What's gonna happen? You will see your evaluation, or your end-to-end evaluation will be created as a new run. So that's mine. Let me this time visualize this one instead. So you click on it, you click on visualize, and let me show you how it looked like. There you go. This is what's gonna happen. Now it is telling me based on your batch end-to-end evaluation, you got accuracy 0.5 with a rate of 0.1, because of course I did have some errors as we discussed, right? And this is the more detailed explanation. So the aggregate result got appeared here with this aggregator flow, which was another flow we ran it. So to wrap up, we use Semantic Kernel as a planner to decide when we need to call that math plugin, which is a Python code. And because of the user question that was a math question, prompt flow was able to call my Semantic Kernel code and get that executed. Then we evaluated that with batch run using prompt flow, and then we called evaluation flow to assess that batch run and give me the final accuracy. So we saw that how prompt flow and Semantic Kernel nicely came together to give me an end-to-end LLM application beyond just development. We can take it further to deploy it as an endpoint to give you a chatbot that does math perfectly, or anything you want based on your plugin definition. So again, if you're interested to have dedicated videos just about Semantic Kernel, I would love to know. Make sure you write down in the comment section. As always, I welcome and respect them, and that would be helping me to make sure that I create something that you love to hear about it. As always, thank you so much, my friends, and I hope you enjoy this video. That's all.
My friend, are you tired? Are you willing to give up? Well, you have reached your limit. And this is the time you need to push. Don't waste this beautiful opportunity. God is with you. Dream big, my friends, believe in yourself, and take action. Till next video, take a good care.